Hello, how's it going? So this is a follow-up on my last two videos, the intro to stable baselines and Gym Retro, and also the PvP mode where you have two models fighting each other in games such as WWF WrestleMania, the arcade game, and Mortal Kombat 2. So here I will just jump right into the PvP details. So I assume you watched the previous two videos where I covered the basics. Otherwise, it will make little sense. So in this case, we have Samurai Shodown. It's a Genesis game and a PvP, which has a PvP mode. And this is a port of the Samurai Shodown arcade game, if I'm not mistaken. So we're going to see a bare bones example with this game, using stable baselines and Gym Retro. So let's get started. So before we dive into the code, we have to check the integration details. So it's pretty simple in this case. So Samurai Shodown was already integrated in the original Gym Retro branch. So in my fork stable retro, I have a link down below in the description. I integrated the PvP part. So the first step is that you need to create a player versus player state. And that's pretty easy. So basically, you just start a versus mode, and then once you started, you save the state. Then after, you need to create two other states. In our case, it's going to be Haomaru versus Wanfu, and then the reverse Wanfu versus Haomaru. So these two states will be used to train the two models. And the last part is in metadata file. You need to add the default player state. So basically, when you create an environment, the retro environment with two players, it's going to use the two-player state by default. And with one player, it's going to use the one-player state by default. So for this game, it's that's pretty much it. Just some additional details not related to PvP. So this game actually uses a script. So if you watch the previous videos about the calculation of the reward function, usually it just takes a few variables and calculates the reward function simply. But in this case, in the case of the Samurai Shodown, you need to use a special script for it, a Lua script. So because there's an issue with the score, and this is quite useful when using directly the variables is not enough. You can use a Lua script to update to calculate the correct reward if you want. So that's a trick you can use for if you want to integrate your own retro game. I can talk a bit more about that in future videos, because it could be especially useful for games that have long-term rewards, for example. So that's pretty much it. So let's check the code. So first, we're going to import retro. So retro, as you might recall, is the wrapper around the console emulator and the game integration, including the calculation of the reward function. So in the case of Samurai Shodown, the Genesis simulator, and also is going to run the Lua script to calculate the right reward. So we're going to need NumPy. And stable baseline, of course. We're going to import the PPO2 algorithm. Like, there's also a couple others available, like A2C, if you want to try. Next, we're going to import the policies, like the CNN policy, MLP policy. So the first model will use CNN, the other one MLP. So import CNN policy, then MLP policy. And next we're going to import a couple of wrappers. I'm going to re-explain a bit what they do later. So it's Atari wrappers, but actually it works with the other consoles. It's exactly the same thing. So a warp frame actually downsamples to 84 by 84, and in a stack, not in a stack, but just download 84 by 84. And to stack them, the last 4 frame, it's done elsewhere. So clip reward, this is to make sure that the return reward is not too big, otherwise it can screw the learning process. And frame stack, this is actually where you stack the frames, the last 4 frames. As you might recall, this is to encode the velocity of the objects. So we're going to create a couple of global variables just for convenience. So the game environment is going to be Samurai Shodown Genesis. You can copy paste this from the folder name. It's exactly the same name as the folder name. Next, it's the first state for the single player, and the first player is Haomaru, and the other one is Wanfu. So I'm gonna just copy paste because it's faster. And then you need the third state where this is actually where you're gonna test the 2 models together, is the 2-player state. And then the policy for your first player, in our case, we're going to use the CNN policy. And the policy for the second player is going to be MLP. So just you call it MLP is a multi-layer perceptron. It's not made for image-based task, but we still use it just for fun, just to demonstrate that you can use different models against each other. So, and then the number of time steps, 10,000. So 10,000 is not enough to learn anything really, but in order to make the example pretty short, it's enough to test. After that, we're gonna make a function to apply these wrappers. Like if you recall the single player example in the previous videos, we just had to create one environment, but in this case we need to create several, so it's useful to have a function that apply the wrappers. So apply wrappers. Parameter is going to be the environment, of course. So first thing is that we downsample the frame to 84 by 84. After that, we stack the last 4 frames. And finally, we clip the reward. Forgot to add last 4 frames. And then we return the environment. Now we create our main function. So first thing, we create the environment for the first model. So retro make. game, we use our global variable for the game, and then the state. So obviously the first state. And we apply the wrappers. Oops. Now once the environment is created, we create the model with the PPO2 algo. So P1 model, PPO2. So policy is the first policy, of course. Policy 1. Environment's the environment we just created. And then verbose mode to true, because you want to see the details while it's training to debug. Once the model is created, we start the learning process. So this is going to iterate for a number of time steps we specify. So total time steps equal to time steps. The typo here. So warp frame also have a typo. Okay. So now once this is done, this is important to close the current environment, because retro cannot be you can only have one instance of retro create per process. It's a bit troublesome, but this is how it works, so you have to close it. So now we can create the other model. So basically it's just a copy paste of the first one. So except that state 2, policy 2, and then P2 model. And then you close it. So basically after that, the two models are trained. And you create, the final step is that you create the player versus the PvP environment. So we're gonna call it MVP in V2P. So basically it's the same thing, retro make function. The game environment is still the same, obviously, but the state is actually the PvP state that we created previously. And also don't forget to players equal to tell the retro environment that we're doing a two-player game. And we have to apply the wrappers as well. So before we start the loop, the play loop, we have to reset the environment. Make sure it's default state. The start state. So we start with our loop. This is where we're going to loop through the environment, get the frame. This is the state of the game. Pass it to the two models. Take the actions, concatenate the actions, pass it to the environment, and then get the next frame, and so on. So first we're gonna render the frame just for debugging, and also to view the final results. And we're gonna get the first model's actions. So P1 model, predict, and then we pass the state we first got from the reset, and then later from the steps. It's the same for the P2 actions, so basically just repeat. After that, we need to concatenate the two actions. So the first part is the player 1 action, and the second part of the array is the player 2 actions. So we need to concatenate in one variable using NumPy. So P1 actions. Okay. So once this is created, we step through the emulator, the environment. Basically, you don't need a reward and info, but you can still return it for debugging purposes. Then step, and then we pass the actions containing the actions of the two players. Now we can check if it's done. If the depends what you want to do, but in our case, we want when the match is over, we want to reset to the beginning. We don't want the game to continue, so we reset the game. Yes. So that's pretty much it. And now, of course, we need to add this when we want to multi-thread our Python script. So this should work. I don't know if I did a mistake, but we can try. Python 3 test. It's just I'm gonna review the code just to make sure it's okay. Yep, true here. And a typo. Times the actions are concatenated. Should be fine. Let's just try it. So this is a bare bones example. Obviously, it's not complete in terms of features, like you don't save the models. It's not a nice display and so on. But we're going to view this later. Okay, so it trains the first model. So as you notice, this is using only one environment at the same time, so we're not multi-threading the process. I'm going to show you an example of how to do this later in this video. If you watch my previous videos, I already showed it with a single player mode with the wrestling game. Okay, so it's almost done. Okay, so that was the CNN policy, and this is the MLP policy now. Should be a bit faster because the MLP policy is, needs less calculations, I think. Wait, I'm not sure if it's actually much less. Seems so. Because the MLP, as you call it, doesn't have any filters. Okay, so this is the result. So since it's trained only for 10,000, it's not very impressive. Like they still do random moves, but you get the idea. So 1-1 this match. Let's see the other one. Okay, Haomaru will win, I think. No, it's 1-4 again. Which quite funny because it's a MLP model and it's not good for image-based tags, but when it's just for a few training steps, simpler models actually maybe outperforms bigger models that takes much more time to fulfill their potential. So if you want to see a more complete example, you can check out my RetroScript project where you have command line options. You have supports saving models and also the tensor board, the logs, as well as supports multi-threading and also a more fancy display such as this one. Amongst other things, you can sync this project and you can directly start using it to train models for PvP modes and or for single player mode. So like I explained in the previous video, the multi-threading part is here. I already explained how it works, but you can check it out here. So basically, if you want to, as explained, if you, it's pretty easy. So you train your player 1 model with model trainer. Specify the states and the game and the number of time steps, and for the other model as well. And then after you use model versus model, which is this script where you use as input the two save models. It's a pretty simple script. And after it uses the in display, it uses PvP game displays for a better display than the debug display offered by Gym Retro. So when you use Model Trainer, it will save in the output folder or the folder you want to use for your output, where you find all your logs and tensor board data as well. It's going to save your model in a zip file, and then you use that zip file to pass to model versus model, and it's gonna play the two. It's gonna use the two models in the PvP mode, such as in the screenshot. So if you have any questions, please feel free to ask in the comment section down below. Also, if you want new features or new games, if you have those type of requests, feel free to ask in the comment section down below. If I have time, I will take a look. So thanks for watching. Don't forget to subscribe and press the like button. Thank you.